Okay, so today we're going to talk about oblique triangles, and in this section we're going to do law of sines. In this chapter we're going to do law of sines, law of cosines, and law of tangents. Okay. First you need to know an oblique. Try saying that word. Oblique. Yeah, an oblique triangle is a triangle having no right angles. Okay. And first, the author gives you the formula for law of sines. And this one we will use for if they give you angle, angle, side. This kind of goes back to what you did in geometry. Side, 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 angle, angle, side. Yeah. Okay, so law of sines we're going to use for angle, angle, side. Okay. And side, side, angle. Okay. And oblique triangles. Here's the formula. And it's actually proportions. It's A over the sine of angle A. Remember, use A lowercase, angle A uppercase, equals B over the sine of angle B. And that equals C over the sine of angle C. Now, you can use any two of those together. Okay? So I could use like A over the sine of A equals B over the sine of B. And to solve a proportion, remember, we can cross multiply. That's one way. You could use like A over the sine of A equals C over the sine of C. Any two of those together. Okay? So this is the law of sines. And this is when you use it. Angle, angle, side, 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 angle. Okay? Okay, so, and we've actually abbreviated it up here, but when to use the law of sines. Number one, when you're given two angles and any side. Okay, and that's the angle, angle side. The other one that we've listed up above is if you're given two sides and an angle opposite one side. Okay? And that's the side, side angle. Okay? Now I want to go through a couple of examples. Say you're given triangle ABC where side B equals 110, angle B is 40 degrees, angle C is 67 degrees. Find, okay, if you're given triangle ABC where side B is 110, angle B is 40, angle C is 67, find side C to the nearest hundredth. Okay, I'm just going to draw a little picture. The difference on these is you're not going to have a right angle. Okay, so none of them should look like a right angle. I'm going to label this as my B is 40 degrees. I'm going to label this as C. And actually I should do that a little bit better. Hang on. 67, so it's going to be a little bit less. 67 degrees. And side B, remember it's still opposite. Angle B is side B is 110. Okay, and we're trying to figure side C. Okay, so C is no longer a 90-degree angle. C is no longer the hypotenuse. Okay, so in terms of what we're given B over the sine of angle B, and C over the sine of C. So you can use any two of those ratios to form a proportion. So we've got B is 110, sine of angle B, so it'd be sine of 40. C we don't know, that's what we're trying to find, and the sine of 67. Okay. Now to solve this, okay, we are going to cross multiply. Okay, we're going to multiply these two. So it's like 110 times the sine of 67. And when we cross multiply, we're going to take C times the sine of 40. Whoops. Sine of 40. And then you're going to do it basically on the calculator. So once you get to this, you can just pretty much punch it in on the calculator. So make sure you're in the right mode. Make sure you're in degree mode. Also, my other students are doing problems where they're rounding to the nearest tenth, rounding to the nearest hundredth. So I would say look at your mode and check to know where the decimals. So I want degree mode, and if you want to leave it in floating or you want to go to 4 decimal places, that's up to you. Okay, so I basically want to take 110 times the sine of 67, and then I want to divide that by the sine of 40. And then they want you to round that to the nearest hundredth. Okay, and I get C is 157.525. So if that's 5 or greater, we're going to round that up. So 157.53 equals C. You agree with that? Yeah? Okay. Any questions on number 1 example? Okay. Let's try another one. Okay, on number 2, if you're given triangle ABC and angle A is 62 degrees, angle C is 31 degrees, and side B is 2000. Find side C and side A to the nearest whole unit. The nearest whole number. Okay. Draw a sketch. And the sketches don't have to be exact, but it helps you as far as solving the problem. So angle A is 62. Angle C is 31. Okay. Side B is 2000. Okay. They want you to find C and A. Okay. You have enough to figure the other angle. Right? Now, in last chapter I said don't use something that you solve for to solve for something else. You're forced on this one. Okay. So add those two together and then subtract from 180. What are you going to get for angle B? 87. Okay. So now we have enough to do B over the sine of angle B equals. Now, on this, which one should you solve for first? You always want to solve for the smallest side first, and it's opposite the smallest angle. So we want to solve for C because it's opposite, it's smaller than angle A. So C over the sine of C. Now, I said it, but you may want to make a note outside. Solve for the smallest side first, and it's opposite the smallest angle. Okay? The reason you do that, because remember, sine is positive in 2 quadrants, so there's 2 possible answers. Okay, so you want to do the smallest one first. Okay, so then we're going to sub in. B is 2,000, and the sine of, now, this is where you take the risk that you figured 87 correctly. If 87's wrong, it throws the whole thing off. Okay, equals C, we don't know, and the sine of 31. Now, from there, cross multiply. So when we cross, and you should be able to do this on the calculator, take 2,000 times sine of 31. Now, you're either going to have to close the parentheses and then press enter, and then divide by the sine of 87. Common error is people divide by 87. It's the sine of 87, and then round to the nearest whole unit. Be 1,031, right? Now, what I don't want to use is I don't want to use that. Okay, so now I'm solving for A. Okay, so I can go B over the sine of B equals A over the sine of A. My B is 2,000. That's given. Sine of 87. A and sine of, what, 62? Okay, and then cross multiply. Okay, so on your calculator, take 2,000. Notice, be very careful. Like, I would not put in sine of 62 times 2,000 unless you have to close parentheses if you put it in that way. So I always put the 2,000 in first, and then times sine of 62. Press enter, and then divide by sine of 87. Okay, and I get A is 1,768 if you go to the nearest whole unit. You agree with that? Okay. Okay. Now, this is the part where I always stop and I say, okay, look at this problem, both these. We used sine, right? Trig function sine. What's the definition of sine? Opposite over. Is there a hypotenuse in there anywhere? We don't have a right triangle. Does that bother anybody? There's no right triangle, there's no hypotenuse, and we just use sine. Okay? So this is where I go through just to show you where the law of sines comes from. Okay? I want this in your notes. I'm not going to test you over it, but I think you at least ought to know, why can you use sine when you don't have a right triangle? We have an oblique triangle. Okay? So put this in your notes. This is a proof of the law of sines. And this is where no right angles are given. Okay, so draw a triangle. Okay, label this as A, this is B, and this is C. And let's say that's an oblique triangle. There's no right angles. Okay, this would be side A. Okay, this whole thing would be side B, and this would be side C. Okay. Now, here's how they do it. It's very similar to what you did in geometry. You drop a perpendicular. You basically force a right angle in there. Okay, and they label this as H for the height, and this is point D. Okay. Okay, so in triangle A, D, B. Okay, so look at this triangle, A, D, B. What's the sine of angle A equal to? In that triangle, triangle A, D, B, what's the sine of angle A? h over c. Okay, now if I solve that for h, multiply by c on both sides, so I get c times the sine of angle A equals h. Okay? Leave that one for a minute. In triangle B, D, C. Okay, so look at the other side. Look at this triangle over here. In that triangle, what's the sine of angle C? Sine of this angle. Opposite over hypotenuse, so h over a. Solve that, okay? Solve that for h, multiply by a on both sides, so we'd have a sine of c equals h. We multiply by a on both sides, okay? Now you use the reflexive property, h equals h, right? So h equals h. Sub this in on one side, c sine of angle A. Sub this in on the other side, equals a sine of c. Okay. Now you can divide by sine of A on both sides. You can divide by sine of c on both sides. Okay. These divide out. Here's your c sine of, and I'm just proving one part of the proportion. The sine of c's divide out, and you've got a over the sine of a. Okay, that's how you can use sine in solving oblique triangles when you don't have a right angle in there. Okay, that should be enough to get you started.